Hi everyone, welcome you again in this short video lecture on the calculation of the per unit calculation of this sequential network that we have done in the last class. So let us just open my let us just show you the problem, and then we have done the sequential representation, but only remaining thing is the per unit calculation, as I have thought that you could have you can do this one, because last time you told that it is you can practice by yourself. So I will do it and try to explain the thing. So let us just share my screen. Um, so this was the problem. So this is the single line diagram has been given. So from this single line diagram, we need to first develop the sequential network and actually do the calculation of per unit calculation of the impedance of for each of the equipment, and then develop the sequential network. In the last class, I have shown the sequential network, the positive sequence network, how we can derive from the single line diagram to a sequential network. Positive sequence is a sequence network, negative sequence network, and zero sequence network. And the impedance for each of these network is simplified with only single per unit calculation. We will follow the same technique here. So let us start. Uh, so I will again take a notepad and try to do the calculation in the notepad, and later if we have time we will try to redraw the sequential network again. So let me just open on the other device. Okay, so we have a generator, and that is given is connected with Y, and let us write down the configuration. The specification is 25 MVA, 11 kV, and Xg double prime is equal to 20%. That can be written as 0.2 pu. Then this one is connected with a generator, so with a transformer, and that is given with this primary side is 10.8 and secondary is 121 kV, and this is 30 MVA, and the reactance is given is equal to 10%, that is equal to 0.1 pu. And then this one is connected, so this was a bus, and this is connected with a feeder, and this is connected with another feeder, and this is connected with a generator here, with a motor. So this motor 1 is Y connected, and this motor is also Y connected with the ground. And the specification here is 121 by 10.8, and this is the same 30 MVA, and X is also same, equal to 10%, equal to 0.1. And this one is the motor. Motor specification is given equal to 7 MVA, 7.5 MVA, 10 kV, and that one is given is 25%. X M is 25%, that is 0.25 pu. So this is the specification given, and we want to convert is all of the pu is given to their respective specification. So that means 0.2 pu is given with respect to considering the base MVA of 25 and 11 kV voltage. Similarly, 0.1 pu is specified on the specification of 30 MVA and on the respective either side of the kV. And similarly, the motor has been specified on their MVA and the voltage. Now we want to find out for the network what is the generalized per unit impedance. So in order to do that, we need to select the base MVA, that is for the whole network. And this one, what we will do, we will, as we have discussed in the last class, we will take the largest MVA for the network, that is 30 MVA. This might conflict with the solution that is given. In the solution, it is mentioned that they have taken 25 as their base, and this has been taken considering that only single generator is connected with the network. But we can always consider that this network is part of a large network. Then this 30 MVA can also be considered as the base. So for our case, as our general conception, general assumption, we have considered for our all the problem, previous problem, we will take this one as 30 MVA, and that will not change of much of the uh, uh, much of the concept of this exercise. Overall, we will learn how to calculate the per unit calculation of perform the per unit calculation of a network. So this SB is 30 MVA. So we will take the base as the 30 MVA. Now about the voltage, we have considered that the voltage of each section has to be taken as their base voltage. But here we have slightly a problem arises because this voltage on the same side is not the same voltage rating has not been mentioned. Especially whenever you consider the transformer primary side, that means here it is 10.8 and here it is 121. But generator voltage is given 11 kV. So these two voltages are not the same. Both are in the primary side, low voltage side. Then also the voltages are not same. So we need to come up with the common voltage. As the generator voltage is 11 kV, that will drive this transformer. So we will take for this section, we will take the base voltage of 11 kV. 11 kV, let's say this is the section A. And whenever we consider this is 11 kV, that means this will override by 11 kV. That means this one will no longer be 121. That will be different than this one. So this will be 11 kV. And that means this one has to be modified, and that we need to do the calculation according to the turn ratio. And that we can find out by the primary side and the secondary side calculation. So as the VB for section A will be 11 kV, for section A will be 11 kV. But if we consider this feeder line, that we need to do this calculation by taking the turn ratio. So we can do this calculation. V1 by V2 is equal to N1 by N2. And from these, we can find out N1 by N2. So N1 by N2 is equal to V1 by V2. And from here, we can find out new V1. So this one will be 10.8 divided by 121. Now we want to find out new V2. So this is equal to N1 into N2 ratio. Now our new V1 is 11 kV. So we need to find out new V2. So let us try write this on prime. V2 prime, that what we want to find. So we will use the same formula. So V1 prime divided by V2 prime is equal to N1 by N2. So that means we can find out V2 prime is equal to N2 by N1 times V1 prime. So that means we can write down this one as 121 divided by 10.8 times 11 kV. So that will give us so this 121 divided by 10.8 times 11. So that will be giving us 123.24 kilovolt. So that means these voltage for this one will become equal to 123.24 kilovolt for section, let's say this is section B. So this is section B. So from here till this part. Now this one now becomes equal to 123. So this one becomes 123. Let us take this one as blue. So this one becomes 123. Now this one will not remain as 10.8, so we need to calculate this one also. So this is section C. Let us consider this is section C. So BV for C, let us write down this one, A, B, and C. C would be equal to, we can do the similar calculation. So this formula can be written as this one. So this is actually number 1. So this will be 1. Okay, so we can do the same calculation for the C part. So V2 would be, V2 prime would be equal to N2 divided by N1, that would be B1 prime. And N2 here is 10.8, and N1 here is 121, and this one would be actually 123. For 123, what would be the value, right? So for 123.24, what would be the value that we need to do calculate? So this is 10.8. If we go back here, so this is 10.8 in the secondary, and primary side is, original primary side was 121. So the primary one N1 becomes 121, 10.8, and new value is 123. Actual value is 123. So we need to do this calculation. So we can do this calculation by 10.8 divided by 121 times 123. Sorry, 10.8 divided by 121 times 123.24 is 11 kV. So that remains the same as 11 kV here. That will be because 11 kV. So VC will be 11 kV for section C. Okay, so we have got our base voltage. Now we need to convert these per unit for each section to their respective voltage. So we will take help of the formula for per unit calculation, the conversion or transformation from old PU to new PU based on the new PU values. And the formula is given. I will just write down the formula, then we will do the calculation based on that formula. So let us find out the formula. Yeah. So ZPU. So we need actually two formula for the whole calculation. So one is ZPU new is equal to, that means per unit transformation, per unit old per unit to a new per unit because of the change of the bases. So ZPU old times, we will have VB old divided by square BB new square, and then we will have SB new divided by SB old. So this is the formula we need to use to transform our values. Yeah. So first we will transform xg prime, and that is given equal to 0.2 pu. And for this section, we have SB, we will take 30 MVA, and BBA is equal to 11 kV. So that means our calculation would be equal to ZPU or G, that would be equal to 0.2 times it is 11 kV, and new also 11 kV because it's the generator, and this will be changed to new one is 30 MB and old one is 25 MBA. As I have taken 30 MBA as base, so we will do the calculation. This is actually square. That will not change much because they will cancel each other. So we will just do the calculation based on this 30 divided by 25 and times 1.2. Sorry, times 2 actually. So 1.2 times 2 is 0.24. Right? So let me just do this calculation again. 1.2 times 0.2. Yeah. So new value for XPUG is 0.24 pu. So similarly, we will do it for the transformer, and transformer is 0.1, and okay, we'll do for the transformer, and transformer is usually given for the primary side voltage, so that will be X, the transformer ZTF1. So this one might confuse with the sequential value. So we will just write down this one as 1 here. And this is the new value is equal to, old one is 0.1. And then the voltage here is, so the formula is old one square, old is 10.8 square divided by 11 square, and then old and new are both same, so 30 divided by 30, so that will cancel each other. So if I do this calculation, then this will be equal to 10.8 divided by 10.8 square divided by, so 10.8 square divided by 11 square. So it's 0.1 times 0.1 is equal to 0.096 pu. And we will take this one as the second one will also be the same. Now the motor we want to, or line, for transmission line. For the transmission line, we don't need to transform. This one has been given as 100 ohm is the reactance. So we need to calculate the per unit for this transformer. So if we do use the formula, and that will be formula for ZPU. So we'll use Z transmission line in PU would be equal to ZL divided by ZB, and ZB is calculated from SB and BB. So if I do the calculation, this is not, so we can do the calculation of the current. IB is equal to SB divided by BB. And then from the, so this is the base, from the ZB, it would be equal to BB by IB, and BB, IB equal to SB divided by BB. So that would be equal to BB square by SB. So that means we have to plug here ZL divided by SB divided by, sorry, this would be equal to BB square divided by SB. And then from here, we can write down, we can use this formula. So ZTLPU is equal to ZL times, so we can inverse this one. So it would be SB divided by BB square. So this one is given 100 ohm and SB is 30, and BB for this transmission line is 123.24 square. So this is kilo and this is mega. If you square the kilo, that will mega, so that will cancel. So if it is otherwise, if it is given in voltage and mega, then it's better to work on the basic values. So this one would be equal to 30 divided by 123.24 square times 100 is 0.197 or 8 PU. So this one is also done. Okay, the last one is the motor that we need to do the calculation. So we'll do the calculation of the motor. Motor is the transformation. So I think this one is clear. So we have found is the basic value is the impedance is given for the transmission line. So transmission line impedance is given. You can write down for the transmission line is TL. So this is TL. Transmission line impedance is given, that has to be converted into. So basic value is ZTL divided by ZB, and ZB we can derive from BV by IB, and IB we can write down as B by BB. So from here we can derive this one. Okay, so last one is the motor. So motor impedance per U, and it has to be new, that means transformation. So that is given 0.25, and so we will write down the formula is BB square, that is the old one divided by new one. Old one is 7. Old one for the transfer, the motor is given 10 kV. So 10 kilovolts square divided by this one is given actual value now, it is 11 kV square, and then as we knew is 30 MVA divided by old one is 7.5 MVA. So that will give us, so here the both the voltage and the base voltage and the MVA both has been changed to a new value. So we have to use both of them. So divided by 11 square times bracket is 30 is the new one, divided by 7.5 is the old one, times 0.25 is 0.83 PU. Okay, so this is the calculation of the per unit. So this is the difference from the previous one, is only difference of the previous one is previous all the per unit calculation is the voltage has been different, the transformer voltage and the generator voltage. So we have to transfer these voltages to appropriate value. So that is the only differences, other than the per unit calculation remain the same. So that's why I thought that you would be able to do this one. Now, once we have done this calculation, now we need to represent the sequential network from this, or derive the sequential network for each of the positive sequence, negative sequence, and zero sequence, and impedance value for each of these sequence. In ideally, in practically, it will be different, but for this problem, we have taken the same value. So positive sequence, positive sequence network. We can derive from this one as, so first one, if we take a look, so let us just share the network now. So in the first network, as I have mentioned, we have to consider the generator, and this generator is connected into Y, each of the Y connected coil, and the ground, the neutral is grounded through an impedance Z, and we will consider this one. And this one can be represented. So we will have positive sequence, we will have an induced EMF, so EG, and then it has its own impedance that is equal to XG or ZG that we have calculated. And then this one is grounded. So this is my ground plane, and that has to be